Alrighty. Hey everyone, good to see you all back. For those of you who are here for the first time, my name is Josh, and I'm going to go over a Chem Phys MCAT video right here. And if you all want to see, look, Junie, that's my cat Junie. There he is. Yeah, he's for emotional support right here. Anyway, I'm going to put him down and let him do his thing. Hey, it's okay. Yeah. But yeah, in this video, I want to teach you all how to master Chem Phys, given that I myself have gotten a 99th percentile on that section. And I know it's a section that many people struggle with. So I wanted to give some very quick tips, and then we will go over a sample passage right in my computer right here. So Chem Phys is an intimidating part of the exam because many of the examiners, they intentionally place it there in the beginning of the exam because they expect people to be very scared on how to do the calculations. And then they will end up wasting a bunch of time. And as a result, they'll tend to get very spooked on the car section of the exam. So that's a big thing that the test takers know students will struggle with. They place Chem Phys there very intentionally. And some of the tips I want to share with y'all in order to overcome the exam revolve around being able to do math fluidly. And one of those tips revolves around using scientific notation. I would strongly recommend that you all memorize this prefix table right here. I'm about to link right somewhere around here. The reason why I say that is because this prefix table is extremely useful on Chem Phys. There will be many questions that you will get that require you to convert nano to a regular unit or to milli to micro or whatever it is. You need to have those units down pat. Another thing about Chem Phys that I would highly suggest that you implement is passage skimming. I would argue that Chem Phys is the one section on the exam where you could get away with skimming passages. And the reason why is because many of the answer choices can be solved simply with only very few pieces of information. For example, you may only need 2 or 3 numbers in order to do a very quick calculation and then get the answer right. So this is why I suggest skimming the passage and going with the advice that I've been giving to many of my students, in that we will not worry about a specific portion of the passage until a question tells us to do so. Because ultimately, the master advice that I have above all else here is that you need to worry about the question stem, read it very carefully, and dissect key words in which you can go back into the passage and then use that info in the passage to work through it. Perhaps you might have to pull up a formula up your sleeve, and then you can get the right answer. So if you don't get anything else out from this video, just note that in order to improve on Chem Phys and the MCAT as a whole, you need to read the question stem very carefully and use keywords to go back into the passage to find the right info to get the right answer. That's really what it is in Chem Phys. Now, also another thing too I would very much suggest is to randomize passages. So don't always do passages on organic chemistry. You need to randomize organic chemistry, maybe do another passage on Gen Chem, and then maybe another one in biochem, and then maybe another one in physics that deals with fluid dynamics, and then perhaps another one that deals with, I don't know, like electricity, and then another one that deals with magnetism. Because the MCAT, it tests you on a variety of topics. Many people say that the MCAT is an inch deep but a mile wide. What they mean by that is that there is a variety of topics that you could be tested on within physics, Gen Chem, OChem, biochem. That's already quite a lot of subjects. And there's subdivisions within those subjects that you need to be very well versed in. So I would suggest randomize your practice. And by doing that, you'll be able to learn how to get caught off guard with pieces of information you don't know. And even if you don't know those pieces of information and you get those questions wrong, review them thoroughly, and that is how you're going to learn new content. Anyway, those are my quick tips about Chem Phys for those of you who are probably feeling discouraged about studying for this portion of the exam. Without further ado, I want to get into a passage because there's only so much advice that I can give you all, and yeah, I think it's just better off that I jump into a passage. Alrighty, I don't know what I'm going to do here, but I most likely might become smaller and the passage will become overlaid. I don't know. I'm going to have to figure it out within this video. That's for me, myself, the editor of this video in order to work through. But y'all don't have to worry about that. I might have to move to the side here and yeah, give y'all space to see. But in the meantime, let's break down the passage. So what I'm going to do is open up a passage on Jack Westin. If y'all don't know what Jack Westin is, it's a very good resource that I would recommend. It's free. They have free MCAT passages. They make 3 new MCAT passages every single day. And it's a resource that I would very much suggest using. So I'm going to hop on to Jack Westin. That's the name of the site right there. And so with Jack Westin, what you can do is you can choose to select certain passages down in where it says sections right here. So I'm going to go into sections and it says AAMC style passages. So I'm going to go ahead and do that. And let's do Chem Phys. Yep. So we can pick Chem Phys, and right here, let's do solubility of teeth. It's testing us in Gen Chem. It's a very tricky subject because a lot of people forget Gen Chem and how to do it. And it's a very tricky subject because a lot of people forget Gen Chem and they forget how to do it, since most people take it within like the freshman or sophomore year of college. Anyway, without further ado, let me turn my brightness and we are going to break down this passage. When food enters the human alimentary canal through the mouth, it first encounters an aqueous environment termed saliva. It is well established that acid-containing beverages and foods, in addition to acids originating from the stomach, are harmful to teeth as these agents contribute to the erosion of tooth surfaces. Okay, so we know that there's acids, and I like to highlight pieces of information that I think the question might ask me on. I can't read the future and I don't know what it's going to ask me, but I can try my best. And that's what I'm trying to do here, and it's going to promote active learning. Soluble impurities in drinking water may also affect the integrity of dental health and strength of enamel and dentin. Enamel and dentin are composed of approximately 80% hydroxyapatite, whose structure is shown in figure 1. When hydroxyapatite is in contact with water, saliva, hydroxyl ions can remove part of the tooth surfaces, They can remove part of the tooth surface during an acidic challenge. So they talk about how you can have hydroxide ions. They can essentially serve to help take away some of the protons when there's acid around the teeth. Long story short, they're essentially trying to say that the teeth is kind of made up of a bunch of these calcium and then phosphate groups, as explained in figure 1, where it says the structure of hydroxyapatite. However you say it. I'm probably butchering the name, but whatever, honestly. Read it however you like, HA. And then they give us the chemical formula where you have 10 calciums and then 6 phosphates and then 2 hydroxyl groups. That's how it is. All right. Oh, this is very important. Whenever there is a passage that says to investigate, scientists hypothesized, scientists wanted to determine, highlight it because it's going to tell you the main idea of the experiment below. To investigate the effect of soluble impurities in drinking water on hydroxyapatite integrity, researchers measured the dissociation of HA in response to water impurities in a strain of mice with a dental composition profile similar to humans. The treatment conditions and results are shown in table 1. So here they have the HA dissociation experiments in the presence of drinking water impurities. So they essentially give Ka and they're showing us essentially these different ions right here, where we have magnesium, copper, zinc, and manganese. And then they have Ka, which is, they give us these Ka values to the order of magnitude of 10 to negative 15th, negative 14th. And then they give us Ky. And then they're saying, note, Ky is an equilibrium constant of HA dissociation. And HA, they're referring to hydroxyapatite, whatever that compound was called right there. And a thing I want to note right here is that this value on the third column right here, Ka over Ky, they're essentially dividing Ka divided by Ky, as obviously I stated. But the thing I want to note to you all is that be in agreement with this. If you have Ka over Ky and it's equal to 1, that means if you cross multiply it, Ka is equal to Ky. However, given that these values are bigger than 1, you have 1.3 and then all these bigger numbers, we can assume that Ky is smaller than Ka, meaning that whenever we have these metal ions present, they're going to cause an increase in dissociation of the tooth, which is not good for our dental health, essentially. Again, I've broken down this passage well enough. You don't need to do all of this analysis when you read it the first time. I'm doing it to your benefit, of course, though. So anyway, without further ado, let's do question 1. According to table 1, the addition of metal impurities tends to have what effect on HA dissociation? Addition of metal impurities. Well, we kind of already answered this question, given that KY is normal HA dissociation. And then when you add metal impurities, the Ka value increases. So we would expect the solubility of hydroxyapatite, aka the tooth, to increase. In other words, the tooth is going to get dissolved. Let's pick answer choice B. Boom. That's what it is. All right. We're going to move on to number 2. What is the value of KY according to the data presented in table 1? It's a very good question, because what we have is that they're asking us to figure out KY. And from the looks of it, it might be tough to figure out because all we have is Ka over Ky. And we're like, we don't really know what it is. However, we are given the value of Ka. So what we can do is put, for example, and I'm going to have to figure out how to write this on my whiteboard. Let me erase this real quick. I will be right back. Please stand by. Okay, essentially going back to this passage. I might have to zoom this out or whatever editing trick that I'm going to do. Long story short, essentially I'm going to write down Ka, which is going to be 1.3 times 10 to the negative 15th. We're going to use the top value because it seems to be the most workable number. Most of the times, I just prefer the Ka over Ky to be the smallest. So that's equal to our Ka, and then divided by Ky is equal to 1.3. And I'm going to show you what it looks like right here. This is the work that I have done. Yeah. So long story short, what my plan is that I'm going to take this number and then cross multiply and divide it. So let me just show you all what I mean right here. This algebraic manipulation. So Ky is going to equal 1.3 times 10 to the negative 15th divided by 1.3. This is the manipulation that I'm talking about in terms of algebraic manipulation. So we're going to take that and divide it by that. Now, keep in mind that we have 1.3 as a antithesis. The antithesis is the beginning portion of the number, and then the exponent is the later. So you find out that the antithesis is 1.3 and the denominator is 1.3. These guys can cancel out to become 1. So that leads our answer choice to become 1 times 10 to the negative 15th. And that is Ky. Ky is a unitless constant because it's just an equilibrium constant. It does not have any units. That is our answer choice, which is going to correspond to answer choice B on this Jack Westin question. Boom. 97% got it. Not bad. That's pretty good. Yeah. All right. That was a pretty decently easy one for number 2. Number 3. Suppose it was determined that the KSP of carbonate substituted hydroxyapatite. So keep in mind that the normal amount of hydroxyapatite had phosphate and actually had hydroxide. But in this case, they're putting carbonate right here. And note the hydroxide is OH minus. So you need 2 of them. Whereas with carbonate, it is CO3 2 minus. So you only need 1 ion. Anyway, they're saying that the KSP is 5.5 times 10 to the negative 28. What is the most likely explanation for why this value is lower than the Ky of the unsubstituted hydroxyapatite? Yeah, because, well, we already calculated the Ky of the unsubstituted hydroxyapatite, but regardless, we need to know that value because they already said that the KSP is lower. And long story short, when you have a lower KSP, that means that it is less likely to be soluble. That's essentially what it is. Anything that has a higher KSP means that it is more willing to become soluble. So something that has a lower KSP is more likely to precipitate in solution. And a precipitate is something that comes out of solution and it can be turned into a solid, something like that. So what they're asking here is that they're asking, why is it that carbonate causes a lower KSP compared to hydroxide? They're trying to find an explanation that fits the bill. We can't really make too much of a prediction here. However, we can read through the answer choices and carefully evaluate them. Carbonate forms a more stable compound than hydroxide with hydroxyapatite. That could make a lot of sense, actually. That carbonate does form a more stable compound, meaning that it is less likely to dissociate. I like answer choice A. Carbonate forms a less stable compound with hydroxide than hydroxyapatite. See, the thing is, I'm not too big of a fan of this answer because the KSP is lower, meaning it's less likely to be soluble, so carbonate should actually fit with answer choice A a bit more. Now, carbonate is more acidic than hydroxide. This might be a tempting answer, but we can't really pick it because we don't know about the specific KSP values here. And that's why I'm not too big of a fan of C and D. They're talking, sorry, I meant to say Ka values, not KSP. Ka is related to acid dissociation, but we're only given KSP, which is related to solubility. So in this case, I do like answer choice A the best. Yup, that's what it ends up being. Yeah, C and D, they were meant to be trap answers because they're asking about unrelated information, which is related to Ka, not KSP. KSP revolves around the solubility of a compound. Ka is more about the acidity and basicity. More really the acidity of a compound. You can determine basicity from Ka. Perhaps I could do another video in which I do that. But that is number 3. Hopefully that makes sense to y'all. Number 4, researchers extracted the remaining HA from mouse teeth to quantify how much HA was lost. To do this, they first had to dissolve their teeth with a strong acid. Which of the following conditions would most likely accomplish this goal? Yeah, so we're not given too much info within this question stem. I'm looking back in the passage and all I could really find is that in the beginning, it says it is well established that acid-containing beverages and foods, in addition to acids originating from the stomach, are harmful to teeth as these agents contribute to the erosion of tooth surfaces. In other words, it's kind of restating the question stem in that it's saying, oh yeah, we already know that acids dissolve the teeth. So I think what this question is trying to ask us is, what is the most favorable acid to dissolve the teeth? And this is a pretty good one, because with answer choice A, we have an equal concentration across the board for all answers of 1 molar. So we know the concentration is not going to make an impact. It's rather the chemical property of the acid. So 1A, which is HCO3 minus, that is the conjugate, that is actually bicarbonate, which is a conjugate base of carbonic acid. A is not even an acid. Well, it can be a bit of an acid, but it's a very weak acid. Arguably, bicarbonate, it could deprotonate to become carbonate, or it could reprotonate to become carbonic acid. Not a very strong acid, because the question stem says that they use a strong acid. It's actually, to be honest, a very weak acid, and it's also a weak base too, arguably. Depending, it could go either way. Bicarbonate is a buffer, so I'm going to eliminate answer choice A. And then B is NaClO4. Okay, here, whenever you see anything with sodium or potassium, what I personally love to do is cross it out. Because in Gen Chem, these guys are spectator ions, which means they don't participate in the reaction. And once you do that, you see that ClO4 minus is a conjugate base, not an acid. So B is wrong too. C, HNO3, or in other words, nitric acid. This is a good answer because nitric acid is one of the many acids we have to memorize in chemistry for known as being strong. Other examples include HCl, sulfuric acid as well. So I'm going to pick C. D, phosphoric acid, H3PO4. While I like this answer, and it does have 3 protons, I will say that phosphoric acid is not a strong acid, and it's known for being a very weak acid. Even the first proton is a weak acid. So I'm gonna have to eliminate D, even though it would be a very tempting answer to pick, because phosphoric acid is simply too weak due to the fact that it's very easy to rip off the first proton, then the second, then the third. Yeah. C is a good choice. Let's see if it's what it is. Nice. It ends up being C because nitric acid is a very commonly strong acid in this case. All right. Hopefully y'all enjoyed that passage breakdown and you found it very, very helpful to see how is it that someone who did very well in Chem Phys goes through the exam and breaks down certain passages. Please let me know in the comments if you want to see a breakdown of biochem and psych soc. I'd be more than happy to do it if this video gets enough views and y'all end up subscribing to me a lot. I would really appreciate it. But in the meantime, keep studying hard for the MCAT, and I hope this video in Chem Phys helped you a lot. Take care.